one time I missed for actually I missed it this time. Even I don't have it.
So we make sure we fill in the 55 and the 5. Now some people distribute through. Remember I told you I like taking the 2.5 and dividing it over right away. So then my T1s match. 55 divided by 2.5 is what? 22 equals 2T1 plus 40. So I have one equation. Repeat over. So the hardest part is spotting arithmetic series 2 sums use long formula, correct? You can do that. Most of you can work your way through it. I've seen it. I saw most of you and all of you are going to get through it because I saw that you're working perfectly fine with it. The hardest part is spotting 2 sums. It says arithmetic and knowing what to do, right? Fill into big formula. So we're going to get 189 equals 9 divided by 2, 2T1 plus 9 minus 1D. So we get 189 equals 4.5, 2T1 plus 8D. Divide by 4.5 and what do we get? 42. Then we stack them. 22 equals 2T1 plus 4D. 42 equals 2T1 plus 8D. And then we can multiply the bottom by -1 if we want. I know I did T1 and D. It doesn't matter if you keep them on this side or the other side. So I get 2T1 plus 4D equals 22. And then negative 2T1 minus 8D equals negative 42. When you add these cancel, we get negative 4D equals negative 20. Divide by negative 4, and D equals what? 5. And then which one do I have to put it back into? Does it matter which equation I put it back into? No, you can put it back into either one, you'll get the same answer, correct? So we found the common difference. I'm going to plug it here because it's open. 42 equals 2T1 plus 8 times 5. So I get 42 equals 2T1 plus 40. Subtract 40. 2 equals 2T1. Divide by 2. T1 equals 1. And you could check your answer. You could go 1, 6, 11, 16, and then add them all up and see if you got it right as well. Okay? When you're done writing that down, can you go back to your booklet that we were looking at yesterday? And finish it up. So this one says for each geometric series. Do I have to say geometric series? Nope. Because we can see it's going 2 to 8, 8 to 32. I'm not adding to get to the next one. I'm multiplying, correct? So I know that it's geometric. Then I write down my knowns. I know n equals 8. I know T1 is 2. I know it's not arithmetic because it said geometric, but other than that, I know it's not arithmetic because it doesn't go up by a constant value. How do I find R? I go term 2 divided by term 1, which is 4, and then I can check it. 2 times 4 is 8. 8 times 4 is 32, and I feel good about myself, right? That I got things right. So I have N, I have T1, and I have R. Which sum formula in geometrics, we're going to the second column. Which sum formula are we going to use? The first one or the second one? Which one has the stuff we have? The first equation or the second one? The first one has everything. The second one is Tn. Is that helpful to us? No, there's no Tn. Remember with geometric, do I have to find n if they don't give it to me? No. Do I have to in arithmetic? Yes. Did I tell you you're going to get a question where you're going to have to tomorrow? Yep. Am I lying? Nope. I know it's there. Okay? All right. So we're going to do S8 equals T1, which is 2, bracket R, which is 4, to the N, which is 8, minus 1 is down here. It's not in the exponent, over R minus 1. So 4 minus 1. So I get 2, bracket 4 to the 8 is not something I have memorized in my head. It's not there. It's never going to be there. 4 to the 8 is 65,536 minus 1 is 65,535. I'm just doing it in 2 steps. You could type it all in at once. I don't really care. Just make sure that if you don't type it in a fraction, if you don't use alpha y equals, or for you it's that alpha length, if you don't use that, you have to use brackets in the top and in the bottom, or do the top and the bottom separate, then divide them, right? Because we don't want to get burnt and not doing our questions right because we messed up on our calculators. So we get 43,690. Is that real? Now some people are like, that's ginormous. How is that even possible? Well, 32 times 4, we're already at 128 for the next one. And then times 4, we're at 512 for the next one. Times 4, now we're in the thousands. 2,048 times 4. Now we're at 8,192. Like, it's growing fast, right? So when you add them all up, you're going to get a large number. Okay? Because the next one you times by 4 is 32,760. It's a pretty big number. Right? Okay. The next one, we're adding, then negative, then adding, then negative, then adding, then negative, then adding, then negative. You're going to get a smaller sum. Right? Because you're adding, you know, a positive, then a negative, then a positive, then a negative. They're going to kind of counterbalance each other sometimes. So, our T1 is 24. Our N is 10. Often people don't spot this one. And our R is negative 12 divided by 24, which is negative 0.5 or negative a half. So we have T1, N, and R. So once again, we're using the same formula. We're going to do S10 equals T1, which is 24, bracket R, which is negative 0.5, to the N, which is 10, minus 1, over negative 0.5 minus 1. What do you guys get? Isabel, what did you get? 16. You agree or disagree? Agree or disagree? Agree. Just so you know, I knew it was right. I wasn't gonna. But people are just there. And... Does 16 seem realistic? We have a positive that's a little bit bigger than the next negative, correct? Then a positive which is a little bit bigger than the next negative. So we're going to end up with a positive, just not very big. Which 16 seems real. Okay? The next one says calculate the sum of a geometric series. So once again, we can pick number 2 or number 3. The fourth one under geometric, are we going to pick that tomorrow at all? No, we're learning that lesson on Friday. That would be really stupid. Pick that equation since we've never done it, and so therefore I'm not going to ask it. Okay? So please don't ever use the fourth one on here because it's infinite geometric and we're not doing that. So the fourth one we're not going to use tomorrow, but we will use it after on Friday. Not on the test. Okay? So we have to write down what we know. We know T1 is 960. We can find R. It's 480 divided by 960, which is 0 decimal. What? 5. And then we know Tn is 15. Oh, crud, we have to find N because it's a sum. Do we have to find N when it's a sum? Only if it's a arithmetic sum, correct? Is this an arithmetic sum? No, it's a geometric. So which formula can we use? Sn or Sn the number 2 or Sn number 3? We know T1, R, and Tn. 2 or 3? 3. right? Because 2 you need n for. Do we know n? Do we need n? The great thing about geometric series is if you don't have n, it's not a non-negotiable. An arithmetic series, T1 and n are non-negotiable. You have to find them if you don't have them. Okay, so we're going to use the third formula. Sn equals r times Tn minus T1 over r minus 1. So we're doing Sn, we just don't know what n is, just stays Sn. R is 0.5, Tn is 15, minus 960 divided by 0.5 minus 1. So we get 0.5 times 15 minus 960 divided by negative 0.5. What'd you get? 1,000? All right, 105. Okay, 12 we didn't do very many of. The ones where like R was a half, so I just kind of told you it was half of it. A doctor prescribes 200 milligrams of medication on the first day. So what is the 200 representative of? T1. The dosage is reduced by 1/2 on each successive day for 1 week. So our R is a half. What is the total amount? When they use total, what are they asking us to find? The total, which is the what? The sum. They're asking us to find Sn. Prescribed to the nearest milligram. So they want to know Sn. Now this is the thing. It halves every single day. So it's half, then half, then half. Is that an R or a D? Well, it'd be an R because if you're halving, you're multiplying by 0.5, right? You're multiplying by half. If you multiply, it's R. So this is geometric. So we need a geometric sum. We know T1 is 200. We know R is a half. And then it says each successive day for a week. So what do we know N is? N is 7, but what do we do? We're going to go 7. So we have T1 is 200. And then we go T2, 3, 4, 5, 6, 7. Right? So we have 7. All right. So we want to use which one? Let's try it out and see what we get. What's half of 200? 100. What's half of that? What's half of that? What's half of that? What's half of that? We should be getting to 6.25. We agree? For our Tn if we want to. Add them all up. What is that? 200 plus 100 plus 375, 287.5. 1, 2, 3, 4, 5, 6. Oops. Keep going. There's another little line down here that I skipped. It's 3 point. And we've gotten past the decimals, which I can add. So we go 375 plus 12.5 plus 6.25 plus 3.125, and we get 396.875, right? Let's try it out with this. So we're going to go use the first one, which is Sn equals T1 r to the n minus 1 over r minus 1. So we're doing T1, which is 200, r, which is 1/2 to the 7 minus 1 over 1/2 minus 1. Type it in. Should have a unit on there, milligrams. Yep. Someone's reading rounding rules. That someone is not me. Let's go. 397. Good thing we have you here. It's my rounding rule reading. I even underlined it. Didn't follow it. It's because I didn't highlight it. Hey, Petrovich? If I had highlighted that, wouldn't have missed it. Yeah. It's true. It's the underlining. It just doesn't drive it home nearly like that color. Yes.
Yeah, James.
Okay. All right. So. We're done. I want you guys, you're going to try this out. Okay? We're going to do fish. Yeah.
Jesus.
Yes, when I think of fish, I think of Jesus. Like, what?
Multiplied all the fish for the people.
Oh, yes, like Jesus.
Come on.
Totally.
Uncultured.
True. Sorry, I didn't know we were connecting it that way. I was like, thought you meant like the Jesus fish. You know, like the what would Jesus do fish? That's where I thought you were going with this. I didn't know you were. But yes, like the multiplying the fish and feeding the people. True. Okay, we're gonna increase. We'll do an increase. Okay. So we have on January 1st, 1996, there were 1,000 fish. The fish increase by 15% per year. They often write per annum in grade 12. Annum just means per year, or they'll go /A. /A means per year. Same thing, they always give it per year, even in grade 12. Fish increased by 15% per year. How many fish will there be on January 1st? Don't know why I went to written. 2005. We're going back in time. So, we always have to figure out two things before we can start the question. Is it geometric or arithmetic? And then is it TN or SN? Right? Those are the two things you have to decide. Geometric or arithmetic? Two, TN or SN? Okay? When there's percent in the question, what is it? Geometric, every single time. When there's the percent, it's increasing by 15% per year, it's geometric. Because we're going to do R equals, and what do we always start with? How much percent? 100%, yep. And because this is increasing, we're going to plus 15%, correct? If it was decreasing, what would we do? Instead of adding 15, what would we do? We just subtract 15 if it was decreasing, correct? And then we have to divide by what? Because we're not allowed to have percent in our R. How do we get rid of percent? Divide by 100. So we get 115 divided by 100, which is 1.15. Does it give me the total or ask me to find the total from 1996 to 2005? So if it doesn't give you the total or the word total isn't in there at all, then it's what? TN, because it just wants to know how much is in 1 year. So term whatever, correct? So we know it's TN. They gave us the amount of fish in 1996, which is T1. How do we get N when they give us years? Subtract them, so we go and then add 1. 2005 minus 1996 plus 1 is how much? 10. And then it's Tn and geometric, and we only have one formula. Tn equals T1 r to the n minus 1. And we're looking for term 10 equals 1,000, bracket 1.15 to the 10 minus 1. And I get, so it's supposed to be below 3517.87, which is actually 3,517 fish. People will say that's 18. No, it's 3,517 and then 0.8 of a fish. You can't just miraculously find 0.2 of a fish. When it's whole items, you round down. When it's whole items, you round down. So we have 3,517 because we're asking in that year, it's technically saying, but it's not saying it. It's saying how many, it should say, how many whole fish will there be on January 1st, 2005? And the amount of whole fish are 3,517, right? We can't just miraculously find 0.2 of a fish and connect it with the 0.8 of a fish and then say we have 18. And the biggest way I can explain this is if you can fit 9.6 cows into a trailer, you can't go, oh, I can fit 10. 0.4 of the cow is hanging out and it's dead. They're all dying. They're all just falling out of it while you're driving. That's what they're doing. So if it's 9.6 cows, how many whole cows can you fit in the trailer? 9. Can't cut part of the cow off and shove it in, it's dead. That's not helpful either. So, it's not enough. And it would be really sad. Okay. Good. All right. We're going to try another one. On, I'll use my birthday, September 8th, 1983, there were what? 100 what? Cupcakes? Okay. There were 100 cupcakes. It's my birthday. I was born then. Of course there's 100 cupcakes. Good choice. Okay. On September 18th, 1983, Mrs. Lepp was born. Two parents in Saskatchewan. Peter, Saskatchewan. It was a great place. It was a great time. It was harvest. Okay. There were 100 cupcakes to celebrate my birth. Yes, of course. This is going to get real bad because we're going to go by years and the cupcakes are going to decrease. So I don't know who's going to eat them in 5 years or whatever, but that's fine. Okay, the cupcakes, this is not really real life. The cupcakes decrease by 10% per year. So per A, which means per annum. I don't know who's eating these by this many years, but it's fine. On September 8th, and we have to pick the same date so that the years are solid. If not, it would have to be like 0.5 of a year or stuff like that. So they always use the same date. So on September 8th, 1989, when I went to kindergarten. Yeah, you guys weren't even thought of. You weren't even a blip in the wall. Because I graduated before you guys were born. That's how old I feel. It's okay. On September 8th, 1983, I think I might be almost at the point where I graduated university before you guys were born. What year were you born? 2004? 5? 4? 5. Yeah, I graduated university in 2006.
Wow.
I'm getting so old. On September 8th, 1989, there were how many? There were how many? This is a really great sentence. Enjoy it. There were how many cupcakes left? It should say how many cupcakes were left on September 8th, 1989, but it's fine. It's not English class, true. However, when I write questions for the diploma, this is not how they would be written. How many cupcakes were there on September 8th, 1989 would be the correct way, but I'm going to be a rebel and write it terribly. On September 8th, 1989, there were how many cupcakes left? It's awful. Enjoy. It's a percent, so it's geometric and it's R. Does it ask for the total number of cupcakes that were eaten over the years from 1983 to 89? No, I would say 0 because it would be disgusting. It would be gross. But continue to the question. It's just asking how many on that date. So there were 100 cupcakes in 1983, so that's the beginning, right? If I said there were 100 cupcakes in 1989, what would it be? It'd be TN, not T1, right? So I could give you the last term and not the first term, correct? I can give you how many are in the last term. But I didn't. I gave you the first. Okay. So T1 is 100. N is 1989 minus 1983 plus 1, which is? I was scared I didn't write the numbers in the right order, but see, 1883. I knew there was something wrong. Wow, I'm really old. I was super old, but now I'm really old. 1883? Like, I'm a vampire. Okay, I'm not. All of the people on YouTube who watch this video, which I think is just Nick. All right. And then, I believe in him. You stop it. You all said you missed him. Admit it.
We should say something, so then like ask him a question for tomorrow and see if he watched it.
Oh, we should.
The word is apple. Okay. Now, N, we already wrote. R, how do we do R? 100%. So we start with, and what do we do? Minus 10% divided by 100, which is 0.90. So R is less than 1, and when R is less than 1, we're decreasing, right? When R is greater than 1, we are increasing. So if it says we're decreasing, it should be less than 1. It's the same thing when you're doing geometric questions. If your R value is less than 1, it should be going downwards, correct? You should be getting smaller because it's less than 1 of the original. Okay, so we're going to do S7 equals S7. Whew, not doing that. T7 equals T1, which was 100, R, which is 0.90, to the N minus 1, which is 7 minus 1, and we get how many cupcakes? 100. 0.90 to the 53.1441. So how many cupcakes do we have left in year 7? 53 cupcakes. So we would have to write, on September 8th, 1983, there were 53 cupcakes left. Right? You just restate the question. That's all you do. I was really good at these, but this question's terrible. It's like kind of like a statement with a question in it. I was just saying that. Okay. Another one I wanted to try. It's going to make it up, but that could go real dicey. So I'm just going to give you one of those. What if I give you X's? Oh. I believe in you. Believe in yourself. Sorry, I want these. Okay, this is an arithmetic sequence. Okay, shh, write these down. In the arithmetic sequence, 5x plus 2 comma 7x minus 4, comma 10x plus 6. Determine term 1. So when you're given a sequence like this, and you're missing x's, there are steps we have to do. Do you remember what we have to do?
Yes.
What do we solve for? D. So we do term 2 minus term 1, and then we do term 3 minus term 2, and then what do we do after that? Set them equal to each other and get your x. This one we get D equals 7x minus 4 minus 5x plus 2. Remember the negative sign has to go to both terms. So we get D equals 7x minus 4 minus 5x minus 2. Then we collect like terms. 7x minus 5x is 2x. Minus 4 minus 2 is minus 6. So you have to watch yourself because you have to remember that if it's a binomial, you have to subtract both. Then here we have D equals 10x plus 6 minus 7x minus 4. So we get D equals 10x plus 6 minus 7x plus 4. D equals 10 minus 7, which is 3x. And then 6 plus 4, which is 10. And then I have them both equal to D, so I can set them equal to each other. So I go 2x minus 6 equals 3x plus 10. Subtract 2x, move the x's together first. Negative 6 equals x plus 10. Subtract 10, x equals negative 16. And that's lovely, but it's no answer. They want term 1. How do I get term 1? Fill x into T1, right? What is term 1? 5x plus 2. So term 1 equals 5 times negative 16 plus 2, which is negative, stop. What's negative 16 times 5 plus 2? Negative 70?
78.
No, I was like, that doesn't make sense. Okay, then I'm going to ask some other things. Let's try. Okay, given my own up here. Okay, number 4, given 1/4, comma, negative 1/12, negative 5/12. Determine the value of D. try these two out. If it's arithmetic, how do I find D if it's fractions? If it's anything, how do I find D? Minus. So I'm going to go -1/2 minus 1/4. What do you get? Go -1/2 minus 1/4. Go. As your calculator know it's a fraction. So I put in brackets, you use the fraction button, right? So you go bracket -1 divided by 12 minus 1/4. So this. What do you get? What do you get on your screen? -1/12 minus 1/4, what do you get? -1/3. You're going to get -0.333333 repeating, right? And then you can go math, enter, enter every time. It'll turn it into a fraction for you if you press the math, enter, enter button. It's -1/3. Done. We know it needs to be negative because it started positive and now it's negative, right? So it's going down by something, correct? At the very least, we know it's a negative number. This one says, Crystal is setting up cans on a display. The display starts with 2 cans, so that's T1. If the 7th row is the bottom row, T7, determine the total number of cans. What am I asking you to find? S what? That's total. Sum of what? Of 7. If it's increasing by 3, what type of question is this? Huh? Pardon? Arithmetic. So that's a D. I'm not multiplying by 3 each time to get the next row of cans. I'm adding 3 cans, then adding 3 cans, then adding 3 cans, right? When I add, it's arithmetic. Even if I add a negative, which technically is subtract. Okay? So, I have n equals 7. And I don't know the last one. So I only have the option of using the long formula, correct? So the long formula is Sn equals n divided by 2 bracket 2t1 plus n minus 1d. So I'm finding S7 equals 7 divided by 2 bracket 2 times 2 plus 7 minus 1 times 3. So I'm going to get S7 equals 3.5 and then 4 plus 18. So S7 equals 3.5 times 22. $77. And if it's a word problem and it's in the written response, you'd say there are a total of 77 cans in the entirety of the display, from the first row to the 7th row, whatever you want, right? So when it says percent, it's a giveaway, it's geometric, right? And if you're just like adding 3 cans each time, or each year, say if they were doing a fish pond, let's say, and no one got to fish and no fish died. It's a really extremely awesome pond. And they start out with 100 fish, and then every year they add 3 fish. But the fish don't reproduce as well, because that would throw it totally off. None die, none reproduce. They're just in the pond, you know? And then we add like 5 more fish every year to the pond. If we're adding 5 fish every year, it would be arithmetic, right? If it's increasing by 10% per year, it's geometric. See the difference? Okay. And then there's just your basic ones like we did, where I give you like a T1, I give you an N, I give you a D, and I ask for Tn or something like that, where you have to isolate those, right? So the best place to practice, is it to go to your textbook and try and do some complicated weird questions? Or is the best way to practice to go through the review I gave you and go through your notes and cover up sections and do those over? That would be the best way to study, right? Don't go try and do questions I didn't assign that are stupid. Because they're stupid. Don't do them. And you have the worked out solutions to your notes, right? So go to an example, cover up the answer with a blank piece of paper and like write in that section. And then go to the next one. Boom, 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 boom. Okay? All right. So